Hey guys, welcome back to my channel. And hey, look, my ceiling light is on. I don't know if that's really any better than what it was before, but whatever, who cares, right? So today's video, I want to talk about the age-old question of, do we really need more engineers? I don't know if that's really an age-old question, but I actually came by a video recently that said more, or I should say less, people are getting interested in STEM degrees, and that we really need more scientists, we need more engineers. You know, we have issues like global warming, and energy crises going on across the globe, not just in the United States, and just like all these issues you can think of for our sustainability and things that we need scientists and engineers to help us solve. And obviously I have anecdotal evidence that says we really don't need a whole lot more engineers, but the problem is that we really need more actually good engineers. I hate to say that out loud, but it's like we need more engineers who are like very good and certain, somebody who can get into research and development and do a bunch of certain things. But anyways, so I passed by, I don't even know what I'm trying to say there, but this is, you can tell this is unscripted, but in any case, I passed by another article, The Atlantic, and they have an article, I'll put the article in the description, but the myth of the science and engineering shortage. American students need to improve in math and science, but not because of the surplus of jobs in those fields. So I'm going to try to read just some passages. I don't want to read the whole article to you guys, but the truth is that there is little credible evidence of the claimed widespread shortages in the United States science and engineering workforce. How can the conventional wisdom be so different from the empirical evidence? There are, of course, many complexities involved that cannot be addressed here. The key points, though, are obviously, there's a lot of different reasons for, why, how come everybody says this, but it's the other way? And that's just, a lot of things fall into that kind of category where they tell you need to get this kind of job or else you're going to fail in life, basically. And there's just stuff like that. But in any case, they go on to say science and engineering occupations are at the leading edge of economic competitiveness in an increasingly globalized world, and science and engineering workforces of sufficient size and quality are essential for any 21st century economy to prosper. These professional workforces are also crucial for addressing challenges such as international security, global climate change, and domestic and global health, like the things I just mentioned earlier. So while they therefore are of great importance, college graduates employed in science and engineering occupations, as defined by the National Science Foundation, actually comprise only a small fraction of the workforce. So basically what they're trying to say is that despite the fact that we all know science, technology, engineering, and mathematics, all of those things are very important, and they help us solve a lot of problems. The problem actually being, though, we have a lot of people being interested in these majors, but then they go out into the real world, and then there's either little opportunity, very unattractive careers, or just no careers at all and just massive layoffs, which I've actually heard. I've more anecdotal evidence, but I've actually seen that at other companies where they actually lay off engineers. Usually engineers are kind of the last ones they lay off. Usually it's technicians or like the workforce people down on the manufacturing floor, but they do lay off engineers as well. In any case, so they continue on with No one has been able to find any evidence indicating current widespread labor market shortages or hiring difficulties in science and engineering occupations that require a bachelor's degree or higher, although some are forecasting high growth in occupations that require post-high school training, but not bachelor's degree. So let's stop right there and realize, okay, so there's a lot of job growth for people who are coming out of high school, but there's not a whole lot of expected growth for bachelor's degrees, which makes absolutely no sense at all, right? Because you've been told pretty much all your life, no, you got to go to college, you got to go get a degree, you got to go, or else you're not really going to go far in life. And there is definitely some evidence out there that kind of contradicts what they're saying here, where people with bachelor's degrees definitely make more money than somebody who's graduated in high school. But the problem is those bachelor degree jobs, which I think this is what is more focusing on, it's becoming saturated because, as I've mentioned in my previous vlogs, they told our classmates and everything, like they just constantly hammered it into our heads. You got to go into engineering, become a scientist, go into mathematics. Like, and they just push it so hard that everybody in our class wanted to be an engineer at that point. And then when you have that, you actually have a saturated market where companies basically just go, oh yeah, this guy, okay, cool. And then there's almost no opportunities for the other people to get those jobs because they've already been taken. And that also follows up with a lot of the baby boomers who are senior engineers at these companies, and there's no reason to hire more engineers just because all the positions are filled. But as I mentioned before, a lot of those baby boomers are now retiring, so you're actually going to have some opportunity to find jobs there. So anyways, all have concluded that U.S. higher education produces far more science and engineering graduates annually than there are S&E job openings. The only disagreement is whether it is 100% or 200% more. And that's a bit of a gap there. Were there to be a genuine shortage at present, and this article I should have mentioned earlier was written in 2014, and it's 2018, so where the hell have I been? This was a year after I graduated, actually, so in any case, were there to be a genuine shortage at present, there would be evidence of employers raising wage offers to attract the scientists and engineers they want. But the evidence points in the other direction. Most studies report that real wages in many, but not all, science and engineering occupations have been flat or slow growing, and unemployment as high or higher than in many comparably skilled occupations. Sorry, I forget how to read sometimes. And I definitely have anecdotal evidence that backs that up, because again, they hammer it into your head so many times, like, you get an engineering job, you'll get really good pay, really good job security. Like, they make it seem like it's this glamorous thing. And in reality, and this article proves that too, my first job, I made $46K. And like, I remember getting that job and getting that offer and going, wait, what? Because if you do your research, you look up electrical engineering and like entry-level electrical engineering, and it is the national average, but the average tends to be about $60,000. So my first job, I was like 20% or more under the national average. And I just remember being so mad at that. So I'm just like, there's no way. And I worked as a subcontractor there. So I thought, okay, I'll work here for a year as a subcontractor. And then after a year, they'll hire me full time and pay me more. And really, I think the full-time guys there were making like $50K, which is still, it's not bad. I mean, it was Fort Wayne. Fort Wayne's cost of living is pretty low. So, and I think the article even talks about geographical differences, but things like that, it bugged me so much that we were making so little for what we were doing there. Anyways, that could be a whole nother video. It is true that high-skilled professional occupations almost always experience unemployment rates far lower than those for the rest of the United States workforce. But unemployment among scientists and engineers is higher than in other professions such as physicians, dentists, lawyers, and registered nurses, and surprisingly high unemployment rates prevail for recent graduates even in fields with alleged serious shortages, such as engineering, which is at 7% at 2014, who knows what it is now, computer science, 7.8%, which I actually find really surprising because computer science should be full of people programming different things. They can, JavaScript, and they can learn CSS, and they can learn almost any language they want and get a job somewhere. So that's actually kind of surprising that's higher than just engineering. And this is actually really surprising too. Information systems, 11.7% in 2014. I'm thinking that's probably lower by now. You guys, I could check later, but it's very strange that that's that high there in 2014, but who knows? That's, even I'm pretty surprised by that. Oh, look at this next fact. Surprisingly, some of the largest and most heavily financed scientific fields, such as biomedical research, are among those with the least attractive career prospects, as a recent Blue Ribbon Advisory Committee reported to the director of the National Institutes of Health. Biomedical PhDs are unusually lengthy and often require additional years of postdoctoral training. Yet after completion, those with such degrees experience labor market demand and remuneration that are relatively low. And I didn't actually know what remuneration was, and it's just getting paid for a service is what it is. So that's another surprising thing too. It's like now there's bachelor's, master's, and PhD. And bachelor's degree kind of gets your foot in the door of engineering, and it's kind of like, I guess in a way you can think it's baby's first engineering. A master's degree will get you into some more R&D. And honestly, in the jobs I've worked at, I've worked with people who have their master's degree and they don't do anything different than what I do. And it's different at each company, I know. But again, anecdotal evidence. I have worked with master's degree coworkers, and I've actually worked with one guy who had a master's degree in mechanical engineering, and he had a really cool senior design project. He made $3,000 less than I did with my bachelor's degree, and that's because I had to negotiate really hard for my salary. PhD students, I've never worked with anybody at PhD. They're often a completely different world. But again, like the article says, you spend all this time, all this money trying to get that degree, and what it boils down to is there's not really a high market demand for these things. I know this article's like 4 years old, but I can't believe I just found it. It's just mind-boggling to me. Moving on. Far from offering expanding, attractive career opportunities, it seems that many, but not all, science and engineering careers are headed in the opposite direction. Unstable careers, slow-growing wages, and high risk of jobs moving offshore or being filled by temporary workers from abroad. Recent science PhDs often need to undertake 3 or more additional years in low-paid and temporary postdoctoral positions. But even then, only a minority have realistic prospects of landing a coveted tenure-track academic position. I mean, just think about how insane that actually is, that okay, so you get your bachelor's degree. That's 4 years down the drain. And some places you can do a bachelor's and a master's in like 5 years. But let's just assume worst case scenario, right? So 4 years of bachelor's degree, about 2 years, I believe 2 years on a master's degree. And then I don't actually remember how long it's for a PhD. That might be another 2 years or something like that. So you're spending 8 years of your life trying to get this high level of education, like I'm finally going to do some research, do all this stuff, only to then be told you need to take 3 or more additional years in low-paid temporary postdoctoral positions, which I'm not even sure whether it's almost like an internship position because at this point you don't have experience out on the field, right? Like when I got my bachelor's degree, I went out and got a job right away because I thought about getting a master's degree, but I was like, well, I'll go out there and see what I actually want to do and then focus on something. And I went out there and you get the experience. Like it's almost more useful to just go out there and get the experience. But the problem is if you want to do stuff like a PhD student would do after graduating, there's no way you're gonna, because I've seen job positions online. To do something like that, you'd probably need a bachelor's degree and then like 15 years of experience with a company. And at that point, who knows what you're doing at that point? 15 years, anything could happen. You could be dead by then, like for all you know. But it's just insane. So you spend all this time and then you end up in a position where I shouldn't say nobody, but your prospects for even getting a normal like PhD job, which I would imagine I would think would be somewhere in 6 figures, but who knows? Like, there's just not a lot of companies looking for that. So, moving on, among college-educated information technology workers under age 30, temporary workers from abroad constitute a large majority. Even in electrical, hey, look, my major, even in electrical and electronic engineering, an occupation that is right at the heart of high-tech innovation, but that also has been heavily outsourced abroad, U.S. employment in 2013 declined to about 300,000, down 35,000 and over 10% from 2012, and down from about 385,000 in 2002. Which is mind-boggling. Unemployment rates for electrical engineers rose to a surprisingly high 4.8% in 2013. So again, this is another thing I would have to look it up and see what it is currently because this was a 2014 article. But it just goes against everything you've been told in your life where everybody, your parents, your friends, stick with engineering, go with engineering. There's so many opportunities. And again, they do mention that it's still better than like other jobs out there. But when they glamorize it so much and then you actually look at the real science and the data that comes out of this, it's like, that's not necessarily true what everybody's telling you. They're just outsourcing a lot of jobs too. Some stuff I guess that could also tie into a lot of electrical engineering jobs right now are defense contracting, like Lockheed Martin, Northrop Grumman, Boeing, like all those big companies. Those are the big attractors for electrical engineers. And then you can make the argument that there's some electrical engineers for like Silicon Valley, but they're very picky. They're even more picky about who they hire, and they've already hired the people that they want to hire. But I will admit that companies like that, like Facebook and stuff like that, they're always looking for more like programming people. They're not really necessarily looking for electrical engineers. But then again, maybe I don't actually know, so somebody can correct me on that one. All right, we're almost there, guys. Claims of workforce shortages in science and engineering are hardly new. This is the fun part. So everything I've said about people encouraging everyone to get into STEM, this is definitely not a new thing. Claims of workforce shortages in science and engineering are hardly new. Indeed, there have been no fewer than 5 rounds of alarm boom bust cycles since World War II. And obviously World War II was a big boom for engineers. So they go on to say, each lasted about 10 to 15 years and was initiated by alarms of shortages, followed by policies to increase the supply of scientists and engineers. Unfortunately, most were followed by painful busts, mass layoffs, hiring freezes, and funding cuts that inflicted severe damage to careers of both mature professionals and the booming numbers of emerging graduates, while also discouraging new entrants to these fields. So yeah, again, this has been happening for decades now, where they say, hey, we need more engineers, and everybody, I mean, there's programs at work that encourage all these kids to do STEM and like get into engineering, get into science. And then there's a ton of like robotics competitions going on in schools, and nobody ever tells you, I mean, obviously it'd be against that program to say, hey, by the way, you're probably just going to be doing paperwork in a cube, and you'll probably lose your soul at some point and not feel anything for the rest of your life. All right, that's a little dark, but I mean, that's the reality is, as an engineer, you don't really do a lot of the stuff that these STEM programs are trying to tell you that you're going to be doing. And you're not, it never really feels like each job has a purpose, but there are definitely times where it just does not feel like you're helping anyone at all. And it definitely doesn't feel like you're actually doing the things you thought you'd be doing. And it's so funny. I guess it's funny in a very sad way that we push these majors so hard, and in the end there's just hiring freezes and layoffs and funding cuts that just prevents these people. So you end up graduating with an engineering degree, and then you just go, well, so who's going to hire me? And everyone's like, I'm going to hire where I got all the engineers we need. So we go on to read, ironically, the vigorous claims of shortages concern occupations in science and engineering, yet manage to ignore or reject most of the science-based evidence on the subject. The repeated past cycles of alarm boom bust have misallocated public and private resources by periodically expanding higher education in science and engineering beyond levels for which there were attractive career opportunities. In so doing, they produced large unintended costs for those talented students who devoted many years of advanced education to prepare for careers that turned out to be unattractive by the time they graduated, or who later experienced massive layoffs in mid-career with few prospects to be rehired. Recent forecasts of looming shortages of scientists and engineers may prove to be self-fulfilling prophecies if they result in further declines in the attractiveness of science and engineering careers for talented American students. So what happens is we have these initiatives for STEM jobs, and they saturate the market with graduates who are like, I'm ready to go out in the field and do things. And if you're like me, it took me a while before I found a job. I've actually gone on Reddit and seen people who have looked for engineering jobs for like a year and could barely scrape the bottom of the barrel. And then so what happens is you get too many, and you get massive layoffs and in mid-career with few prospects to be rehired, because you've worked at a gas company, or not even a gas company. You're working at like a company that does a very specific thing. They have to lay you off because they've already spent too much money and they need to get rid of you. And then what company hires them when that company was the very specific thing? You basically have to like move to another state or do something else or learn a new skill. And it's just like, it's just mind-boggling that this stuff happens. But what they also need to consider is that you saturate the market with graduate students. You know, people like me. Well, I guess I graduated 4 years ago, so maybe I'm not even in that market anymore. So you hire, or you make these initiatives to teach all these kids, and they all get their degrees in this field, and then they go out there, and then when you even do get a degree, or you do get a job, and now you're sitting in a job where there's a ton of engineers, and you become a number. You're employee 247. And you kind of get overlooked. So there's a very important thing you need to do at a job where, as a manager, you spread the tasks out. So like Tim does that job, and Charlie does that job, and I don't know, Jimbo over there is going to work on this task. The problem is when you hire more and more engineers, now your tasks are getting spread out way too thin, to the point where I have experienced where you work on a task, you get it done in an hour, and then you ask for more tasks, and then they're like, yeah, it's gonna be kind of slow today, so there's nothing we can do for you. And you have to sit at your desk for the next 6 hours or 7 hours or whatever it is, just kind of figuring out what the company does and, you know, trying to read schematics and whatnot. But so then there's that aspect of it too. And then there's always the potential, like they said in this article, like you do that, like you get the job and then you do some boring stuff for, let's say, 10 years. And then they have layoffs midway through your career. And then it's just like, okay, I did, you know, menial engineering tasks for 10 years, like nothing special, filling out spreadsheets and stuff. And now they've fired me or laid me off. And now I got to go find a job at another place. And these other places, they'll ask you questions like, oh, what'd you do at your last job? And you kind of have to spice it up a little bit. You can't just say, oh, I worked on spreadsheets. And like some companies will be okay with you just working on spreadsheets, but like most companies are going to say, well, what kind of analyses did you do? And what kind of reports did you fill out? And you're like, there was another guy who did that. And they're like, oh, okay, that's cool. Well, bye. So this article, there's a lot I kind of left out still, but I saw this article and I definitely wanted to bring this to everybody's attention, just to kind of bust the myth that, you know, like STEM jobs were critical and we need them. And I mean, I don't want to discourage people from going into these fields because they are important, but we need to address the actual issue that's occurring, which is there's actually not a whole lot of job opportunity for these kind of positions. Now, if you go into engineering, like there's normally enough positions for technicians, and that's definitely a science technology major. Sometimes it's not even a major. But so like the way the future is going, we definitely need more people to be educated in these fields. But the problem is you're probably not going to become a scientist, and you're probably not going to become an engineer. And even if you do become a scientist or an engineer, it's not going to be glamorous. It's not going to be anything they've even taught you in school. It's just going to be, more than anything, it's probably going to be more program management stuff than anything. Just managing tasks, filling out spreadsheets, and signing forms, and maybe a little bit of analysis here and there. But a lot of the analysis I've come to learn is just common sense stuff. So it's just, there is a problem that we need to be aware of, and we need to just make sure we try to address it for the future of these people who are getting degrees and saturating the marketplace. Then they end up just working at Wendy's anyways. So anyways, feel free to write in the comments how you feel about this. Correct me on a bunch of stuff if I'm wrong, because who knows, I'm probably wrong about a bunch of stuff. Like I said, the article will be in the description. So good luck out there. Make sure to subscribe if you want more videos like this. Write in the comments what you guys want me to report on some more. And if you like the video, like it. Wow. So I'll see you guys in the next video. Bye.